Now that you've got the basics of similarity, let's try working with this concept a little bit, keeping in mind the two things that makes polygons similar. One, all corresponding angles are congruent, and two, all corresponding side ratios are proportional. You've got problems, well I've got similar problems. Let's see if we can work them out together. Here we want to determine whether the pair of polygons is similar, and we've got to justify our answer. So, I see I've got two triangles here. First, are corresponding angles congruent? Well, looking at A, I've got one congruent line, and D, I've got one congruent line, yes. B, I've got two, E, I've got two, yes, and C, I've got three congruent lines, F, I've got three congruent lines. So, our first check is a yes, all corresponding angles are congruent. Second, are side ratios proportional? Alright, well let's take a look here. I've got AB congruent to DE, I've got BC congruent to EF, and I've got AC congruent to DF. Well, if all my sides are congruent, then of course they have to be proportional because they're the same exact values. So, yes, my side ratios are proportional. Therefore, since we've checked off both our similarity conditions, we can say triangle ABC is similar to triangle DEF because all the corresponding angles are congruent and all corresponding side ratios are proportional. Here we've got a different scenario. We've got polygon ABCD and we've got polygon EFGH. Let's see if these are similar. First, are the corresponding angles congruent? Well, I see that A is congruent with angle EBF, DH, and C is congruent to G. So, yes, all of our angles are congruent. Check off condition number one. Condition number two, are the side ratios proportional? Now this time we don't have congruent sides, so we're going to have to set up some ratios. Let's go ahead and do that using our corresponding sides. I'm going to start with AB over EF. That's going to be 7 over 3.5. Next, let's go ahead and do BC over FG. That's going to be 10 over 5. Next, let's take CD and GH, which will be 12 over 6. And lastly, let's take AD and EH. That's going to be 6 over 3. So we need to ask ourselves, are all of these ratios equal? Well, 7 divided by 3.5 is 2. 10 over 5 is 2. 12 over 6 is 2. 6 over 3 is 2. So yes, all of these ratios equal 2. Now that we've confirmed condition number 1 and 2, we can conclude polygon ABCD is similar to polygon EFGH because all the corresponding angles are congruent and all corresponding side ratios are proportional. Let's look at a couple more examples. Here we have two triangles. Right off the bat, I notice that the angles are not congruent. So, since those angles are not congruent, these are definitely not similar. Looking at these two rectangles, I see that all the angles are congruent, so that's good. But if I set up my side ratios, I'm going to get 7 over 6 and 6 over 5. These are certainly not equal. Therefore, these polygons cannot be similar. An important thing to know is you may need to rearrange shapes or look at them differently to see their corresponding parts. For example, these shapes below are not necessarily arranged in the same exact direction. However, if we picture this second shape oriented a little bit differently, you could see that Q corresponds with U, P matches with R, M matches with T, and N matches with S. After picturing those differently, you could better compare side ratios and angles. Sometimes you have different shapes built into one another. For example, here below, we could see a triangle here, and then a bigger triangle if we outline the outside of that. Those shapes might be similar as well, so you have to consider that too. Here's a different type of example. We're going to use our knowledge of similarity to find certain things. Here two polygons are similar. They're telling us that. We want to write a similarity statement, then find x, y, ut, and the scale factor. Starting with our similarity statement, the easiest way to do this is to see which angles match up with which other angles. Doing that, we'll get RSTUV is similar to ABCDE. Next, we want to find x, so I've first located x here as a side length. Let's go ahead and set up a ratio with its corresponding side. That's going to be x over 3. Since these are similar, we know that has to be equal to any other side ratio. So let's find a ratio that we do know. How about the ratio 18 over 4? Because we know the value of ST and we know the value of BC, and neither of those have a variable. That'll give us x over 3 equals 18 over 4. Keep in mind we have to stay consistent using the left shape first. We used x over 3, so that means we have to use 18 first over 4. If we cross multiply, we'll get 3x equals 54 and an x value of 13.5. Next, let's see if we could solve for y. So we want to do the same thing, set up a side ratio. Well, we've got y plus 2 over 5. And why not use that same side ratio we used before? We could set that equal to 18 over 4. Now to solve, we can cross multiply. That'll give us 4y plus 8 equals 72. Solving from there, we'll get y equals 16. Now that we've got x and y, we want to find the value of ut. Well, looking at our polygon, we have ut equal to y plus 2. And since we know the value of y is 16, we could just plug that in, giving us 16 plus 2, and a ut value of 18. Lastly, we want the scale factor, and the scale factor is just any of the side ratios. We could use any of these sides, but why not choose one without a variable, since that's just going to be a little more simple. Let's go ahead and stick with 18 over 4. And if we set our scale factor equal to 18 over 4, we could simplify this fraction. Always want to simplify, and since 2 goes into each of those, we're going to get a scale factor of 9 over 2. This assignment is going to have you applying your knowledge of similar polygons, so do your best and let me know if you have any questions.